In this lesson, we'll talk about geometric series and partial sums. Um, let's review what we've learned with arithmetic and geometric sequences and series. So arithmetic sequence has this formula. Arithmetic, the sum of an arithmetic sequence looks like this. And here's a geometric sequence, the explicit form of a geometric sequence. Here's the nth partial sum of a geometric sequence, and with a geometric sequence we can add an infinite number of terms, and the sum will converge. So we can find the sum of an infinite number of terms. And then there's a manipulation, a combination of these two formulas. You can make this turn into that, and for number 67 we will use that formula. That might help in some of those problems. Since we're dealing with exponential expressions, let's review how to solve an exponential equation. If there's an exponential, meaning the variable is the exponent is a variable, then we would use a logarithm to solve the equation. And this says, to what power do you raise 4? To get 4 to the nth power, you raise it to the nth power. So that's how that all cancels. This is a correct answer, but if we wanted a decimal, we would have to enter it like this in the calculator. You could also enter it like this, and that would be the same value. Alright, so here we have a series, and we would want to verify that it is geometric. So we look for a common ratio by dividing 14 by 8, and we get 1.75. Here we would divide 24.5 by 14, 1.75. So that's the common ratio. In this problem, we want the sum of 6 terms, so 3, 4, 5, 6. We would want to find the long way to do it, or one way to do it would be find all of these terms of the sequence and then add them together. But we can use a formula for that, and that is so we need the first term is 8, 1 minus 1.75 to the 6th. The 6th partial sum, so that's how we can, another way to describe that, and we'll get 295.71. So 11th partial sum is just another way of saying find the sum of 11 terms. So go ahead and pause the video to try that one. We need to find the common ratio, negative 24.5 divided by 7, and we get negative 3.5. 85.75 divided by negative 24.5, negative 3.5. And we want the 11th sum, the 11th partial sum, and that is a1, 1 minus r to the 11th over 1 minus r. S11 is the first term, 1 minus negative 3.5 is the common ratio to the 11th power and that sum is 1,501,877.34. And now these types of questions are just making sure that you know how to manipulate the equations. Maybe you have to be a little creative and ask a different looking question. And also when it says the sum of the first n terms, we need to find out what n is, but since they give us the value of the nth term, we can actually find this number n, and then we can find the sum. When you get questions like this that are a little unfamiliar, always start with a table to make it look more familiar. And this is what we know, starting here, ending there, and the common ratio is negative 4. We're going to multiply by negative 4, and that gives us 32, negative 128. The long way to do it would just be keep multiplying by negative 4 until you get to this number, and then you would know what n is. So a shorter way to do that would be using this formula. We know that the nth term is 131.072 and the first term is negative 8. Common ratio, negative 4. And now we can just solve for n and we'll know what how many terms there are. So let's break that up. We have negative 4 to the n times negative 4 to the negative 1, and that is going to give us, this will be a negative 1/4. And we'll have to multiply both sides by negative 4. To cancel that. and we can just reduce that. It'd be a positive, and we end up with 65, 536. And in order to do this on the calculator, since we're not going to have log of a negative on the calculator, that's an imaginary number, we can just keep track of, leave that there and solve it without the negative for now. And that means we'll have natural log. We could have done log base 4. Oops. You can do this in fewer steps. I'm just showing all the steps. And then divide. And this gives us 8. So now that we know that, well, I guess that wouldn't have taken that long. We could have just done it in the table, and that's an 8. So we want to find the sum of 8 terms. The first term, 1 minus r to the 8th over 1 minus r. And that gives us so that might seem unreasonable to have a sum that's less than the last term, but remember that we are alternating the sign, so the sum can be and will be less than the last term. All right, so we understand, we've used sigma notation before. So with this one, let's just write out, let's expand it, and then we can analyze it the same way we just did. All right, and we have, if we put, starting at 2, put a 2 there, and that'll give us a 1, so it's 3 times 5. If we put a 3 there, that'll be a 2. 5 squared is 25 times 3 is 75. And put a 4 there, we get a 3. 125 times 3, 375. But all we need to do is look at this, and that's going to be 75 divided by 15 equals 5. So we know the common ratio. And let's look at what we need for the sum. We know we want to add all these up. Sn equals a1, 1 minus r to the n over 1 minus r. Well, we know the first term is 15. We have to be careful, though, in how many terms we're adding up. 1, 2, 3, 4, 5, 6. We are really only finding the sum of 6 terms, with the first term of 15. Common ratio is 5. Oh, this should be a 6. So, yeah, make sure you are careful about this. When this is not a 1, when we don't start at 1, we don't want to just assume that we're adding up 7 terms, so make sure you're counting how many terms there are, and that'll tell us what exponent to use. Pause the video and try finding that partial sum. So if we put a 16 there, it'll be 2 to the 15th, so 0.5 times 2 to the 15th. And we're going to keep on going all the way to 31, and that'll be 0.5, 2 to the 30th. We want to find and we just have to determine what n is, because we know that the common ratio, if we found the next term, we would see that the common ratio is 2, and also the common ratio appears as the base of the exponential. So there's the common ratio, and we saw that up here too, that the base of the exponential, the base is the common ratio. So we know r, we know the first term. All we have to do is figure out how many terms there are. So if that's the first term, how many more terms is going to get us to 31? And be careful that we don't just do 31 minus 16, which would give us 15, because that's not counting this term. So we need to say that there's going to be 16. And if you want, one way to do it would just be, go 31 minus the previous, and that will tell you how many are right here. There's 16, so then we know n is 16. The sum of 16 terms starting at 0.5, 2 to the 15th, 1 minus 2 to the 16th, and we get 1,073,725. Alright, so now we have a series, an infinite series. We're not finding a partial sum. We have to see if this will add up to a number, if it will converge. So let's look at what's happening here. We can see that we are dividing by 3 or multiplying by 1/3 times 1/3. The common ratio is 1/3. Keep multiplying by 1/3, and we'll get to 1/3, 1/9. And the partial sums, the first partial sum is 9, 12, 13. These are going up by a smaller and smaller amount, 9, 12, 13, 13 and 1/3. and then we're still in the 13s here, and it turns out we're going to be approaching, if we continued this, we would see that we are approaching 13.5. And we can see that in the formula. If we look at this formula, the sum of infinite terms is a1, 1 over 1 minus r. That works only if this is true. And our common ratio is 1/3, so 1/3 is less than 1. That means we can use this. The first term is 9. One minus 1/3 is 2/3. And that gives us 27 over 2, which is 13.5. And here we just have sigma notation, but it still is just saying the same thing that was in the previous problem. We have a geometric sequence that we're adding together, and we have an infinite sequence that we're going to add together, and that's called an infinite series. Pause the video and try that one. We're starting at 4, so let's see what the first term is. That would be a 3. If we put a 4 there, then we have a 3, and we get 0.032. If we put n as a 5, put a 5 there, we'll have a 4. And that's 0.0064. Let's look at what's happening with the sum. This is an, Sn is 0.032, and then we'll get 0.0384. For the next part of the sum, put a 6 there, and we get an 8 and a 4. And we could continue for the, and we see that the common ratio is 0.2. Since the common ratio is less than, or is between 0 and 1, then we can find the sum of an infinite series. So we're going to take the first term, 0.032, and we can do it without a calculator if we just write, that's 32 over 1,000, and this is 8 over 10, 10 over 8 because it's a reciprocal. So then we have 32 divided by 8 is 4, and this will reduce to 100, and we have 0.04 as the sum. Alright, and pause the video and try that one. Alright, if you put a 1 there, it's 1 minus 1 is 0. 0.8 to the 0 is 1, so that's 120 times 1. And here we have 120. If you put a 2 there, 2 minus 1 is 1. So we would go 120 times 0.8, 120 times 0.8 squared. And we see that we're multiplying by 0.8. So the common ratio is 0.8. And if you know the common ratio, and that is between 1 and -1, so now we know that there is a sum for this series. The series converges, and we can find first term 1 over 1 minus r this is 2 over 10. So this is 10 over 2 because the denominator is 2 over 10. And we can reduce 60 times 10 is 600. And that's the end of this lesson.